Alright class, today we're going to be talking about volumes of prisms and cylinders. The volume of any cylinder with a radius, r units, and height, h units. The formula to find that is V equals pi r squared times h. Now our V stands for volume. Okay, our pi r squared is our base. Okay, so pi r squared is our base. Now, on the EOC or star formula chart, you might see it as base times height. And let me show that to you real quick. So it's going to be down here at the bottom where it says volume, and prism and cylinder have the same formula, and that is your volume and your base times height. And just remember, your base of a cylinder is a circle. That's why here I have it as pi r squared, just as a reminder. Okay, for this first problem, we have our radius as 4 meters. Let me write that a little bigger. 4 meters, and our height is 10. Now remember, the height is the the distance between the two bases. So this 10 is the distance between our bottom base and our top base. Okay, and the formula that we're going to use is base times height. Okay, which is pi r squared. R squared is 4. So pi 4 squared times our height, which is 10. Okay, and when we multiply this all out, we get 502.7 meters cubed. I want y'all to look at the meters cubed. This is different from our area. Area is squared, and when we're dealing with volume, we cube it. Okay, number 2. Here's our center. So our diameter of our base is 12, and the height of our cylinder is 6. Okay. Also, I want to point out, you can see sometimes it will give you the height right here on a cylinder, but you may also see the height drawn right here. I mark it right. There we go. You can also see it right here, and just know that it is orthogonal or perpendicular to our base. Okay, so that's 2 different ways you can see it. So the formula that we're going to use is pi r squared times our height. Okay, our radius in this problem is going to be half of our diameter, so half of our diameter is 6. So it'll be pi 6 squared times our height, which is also 6. And that comes to 678.6 feet cubed. And that is it for cylinders. And now we're going to move on to finding the volume of a right prism. Okay, the volume of a right prism with the length L, width of W, and height H is found by doing length times width times height. Okay, I also want to bring to your attention length times width is our base. Okay, so for instance, in this problem, our base is a rectangle, so we just do length times width. So here, base times height. Okay. Oh, and let me show you the formula chart again. Remember, it's in the same spot as our cylinder because it's the same formula that we use. Okay. For this problem, we have a width of 9, a height of 33, and a length of 24. So we're simply just going to do 9 times 24 times 33. And when we punch that into our calculator, we get 7,128 feet cubed. Okay. Now, number 2, we are going to have to pull in some of our knowledge from chapter 10. I'm going to zoom in on it to where we can see everything that's happening in it. To find the area of our base, remember, we have to know our apothem, and we have to know our side. Because remember, the area of our base is our perimeter times our apothem divided by 2, and then our formula for volume, we would multiply that by our height. Okay, and so remember how we find this, our angle here. Remember, we take 360 and we divide it by the number of sides. And when we divide 360 by 6, we get this whole angle to be 60 degrees. Okay, and remember, our apothem divides that angle in half to where this angle right here is 30. Okay, and so we have that our side is 10. Our apothem divides our side in half, so that makes this right here 5. And if we use our relationships of a special right triangle, a 30, 60, 90 triangle, we know that 5 is our short leg. And to find our apothem, we're going to do 5 times the square root of 3. Okay, and to find our perimeter, we simply multiply our side length, which is 10, by the number of sides, which is 6, and we get 60. So to find our volume, we're going to do 60 times 5 square root of 3, divide that by 2, and multiply that by our height, which is 12. Oh, and I'm running off the page. There we go. Okay, let you take a moment. Now, we can reduce our 2 and our 60, and when we reduce that, we get 30. 30 times 5, we get 150. And then when we multiply that by 12, we're going to get 3,107.7 centimeters cubed. And I multiplied the square root of 3 in there to get that. Okay, moving on. Next, this is section 12.5 here. Let me write that here. When we find the volume of perimeters and cones. This volume, I'll show you here on the EOC chart, but it can be shown several different ways. We can have it shown as 1/3 pi r squared times the height, or we can denote it as our base, 1/3 base times height. And then we can also denote it as base times height divided by 3. Okay. To find our volume of a cone, we're going to take our height, which is 5, and we're going to multiply that by the area of our base. And the area of our base is a circle, so that's going to be pi r squared times our height, and then we're going to divide that by 3. Okay, when we plug in our radius into our area of a circle here, we get pi 3 squared times our height, which is 5. Divide that by 3. Okay. And when we punch this all in, we get 47.1 meters cubed. So volume's not too easy. Not too easy. It's not too hard. If you know your formulas, it's fairly simple to compute. And this shape here and this cone, we're given our whole diameter. So if we want to find our radius, we're just going to cut that in half. So our radius is 6. If we want to find the volume of this, we're going to do pi r squared times our height, divide that by 3. Then we're just going to substitute in what we know. We know that our radius is 6 squared, times that by 10, divide by 3. And when we punch that in our calculator, we get 301.6 feet cubed. Not too bad. Okay, and we have one more page that we have to do here. Take a moment and pull that out. Okay, so the next thing that we're doing is we just did cone. Now we're moving on to finding the volume of a pyramid. Okay, oh, and let me go back because I forgot to show you how to find the cone on our EOC chart here. And there it is right there. So cone and pyramid, they have the same formula. Volume equals 1/3 base times height. Here I give you s squared times height divided by 3. Well, my s squared is the area of my base. And in this right square pyramid, my base is a square. So that's why we're using s squared. Okay, so if this is a square, then that means each one of these sides are the same. Okay, the height of my pyramid goes from my vertex, where 4 of my faces meet, and then it forms a right angle with the center of my base. Okay, so if I was to write the formula here, I would do s squared times our height, divide that by 3. My s squared is 12 squared times height, so that's 15, divide that by 3. 12 squared is 144, and when we multiply that by when you multiply 144 by 15, divide by 3, we get 720 feet cubed. Okay, and for this pyramid here, we're given our base again. It's a little different because we're given our slant height. Okay, remember our slant height is slanted. It's not perpendicular to our base. Okay, so if we look here, let me get a different color so you can see it a little better. This forms a right triangle with our height and the apothem of our base. Okay, so this is a right triangle right here. So if we know that this is 13, okay, then we know our hypotenuse. Now we also know if we go from the center of a base out to the side, that's our apothem, right? Well, our apothem divides our base in half, and since we're in a square here, this is a square, this apothem is parallel to this, so this is also going to be 5. So that's 5. So now we can use Pythagorean theorem to find this triangle. And this is a special right triangle. This is a Pythagorean triple, so we know that this is a 5, 12, 13 triangle. So now we have the height of our pyramid. Okay, so our formula is s squared h divided by 3. Our s is 10. So 10 squared times our height, which we found to be 12 when we use Pythagorean theorem, or if we recognize that it was a special right triangle, divide that by 3. And when we punch this in our calculator, we get 400 inches cubed. Okay, and now we're on our last shape that we're going to be finding the volume on. This is the volume of a sphere, and this is chapter 12.6, if you wanted to follow along with the book. Okay, the formula for finding the volume of a sphere here that I have is volume, which is 4 pi r cubed divided by 3. Well, this is also the same thing as 4/3 times pi r cubed. Okay, and on our EOC chart, the volume of a sphere is our last volume, and it's right here, and it is written as 4/3 pi r cubed. Okay, so it's just a matter of notation. You know, it's the same thing. You can write it either way. You can write it this way or this way. Okay, our radius can be written there. Okay, so this is the radius of the sphere. Okay, our radius can also go right here. That is also our radius. Those are the same. Now, if I was to extend that, that becomes the diameter of my sphere. Okay, now the circumference of my sphere is my dotted orange. It can also, this right here is also the circumference of my sphere. Okay, so there's multiple ways we can look at this. For this problem here, we're given a radius of 3.5. Let me switch markers here. Keep it consistent. We're given a radius of 3.5. So then that's all we need for our formula, which is 4 pi, and then we plug in our radius, which is 3.5 cubed, divide that by 3. And when we plug this all in, we get 179.6 inches cubed. The last one that we're dealing with, it gives us our diameter. So if we wanted to find our radius, we would take 4.2, divide that in half, and that's going to equal our radius. So from here to there is 2.1. So we're going to do 4 pi times 2.1 cubed, divide that by 3, and we get an answer of 38.8 feet cubed. So this concludes our notes for chapter 12.4 through 12.6. I will see you in class, and have a great day.